Why is there so much noise in this thing? The audio feed is terrible. Okay, so I think this is a much stable and better sound. So math questions and revision. Let's So we have to solve this question and simplify it as much as possible. So you have 3m divided by 9m squared minus 1 minus 1 over 2 into bracket 3m plus 1. And bracket closes, so we have an equation like this. I think we are out of frame, so let me rewrite the question. So we have 3. Hopefully that has been captured for us. Over to this side. So we have 3 divided by 9m squared minus 1 minus 1 all divided by 2 3m plus 1. So how do you solve this question? So that's the question we have, and we should do our best to see if we'll be able to handle it. So 3 divided by, more like algebraic expressions, but it's in the form of a fraction. Algebraic expression, more of a fraction. So what is the answer to this question? What is the answer to this question? So the first thing we have to think of is the denominators. So we have the denominators being 9m squared minus 1 for the first fraction. And then we have 3 into bracket 3, 2 into bracket 3m plus 1 for the second fraction. So that's what we have at the moment, and that's what we'll be working with. But I want to do one thing. one important step I want to take is this. You see this 9 out here? This 9, yeah. This 9 is the same as 3 squared. I hope you've got that. This 9 is the same as 3 squared. Meaning this 9m squared can be written as 3 squared m squared. Yeah, basically, it can be written like that. So we can rewrite this 3m squared as 3 squared m squared, which also means we can write it as 3m all into brackets squared. I hope that makes sense to you. Yes, hopefully it does. So let's replace the 9m squared. Let's replace it. Let's replace the 9m squared. So you have 3 divided by 3m all squared. So basically, we've just transformed the form of this 9m squared. We've not changed anything. And then you know that 1 is the same as 1 squared. We can rewrite 1 as 1 squared, 1 exponent 3. It doesn't really change anything. So we can decide to restructure this 1 to be 1 exponent 2. And the reason is simple. When we're solving this kind of questions, our ultimate aim is to see if there is a way we can get difference of 2 squares. That's basically the reason why we are taking these necessary steps. We are trying our best to see if we can convert this number into difference of 2 squares. So we are done dealing with this. So let me just repeat the next one. That is 1 over 2 3m plus 1. So we have this done for us. Easy peasy. So that's a nice, a wonderful step out there for us. Now we can expand this bracket into difference of 2 squares. Let's expand this bracket. This 3m squared minus 1 squared. Let's expand it. So you have 3. Let's move down a little. We have 3. 3m squared minus 1 squared is the same as 3m minus 1 times 3m plus 1. Yes, it's the same thing. So if we have 3m squared minus 1 squared, difference of 2 squares, think of it this way. We have a squared minus b squared is the same as a minus b multiplied by a plus b. A minus b multiplied by a plus b. And I can prove that to you. So let's just take a little detour for me to explain that to you really quick and see. This bracket out here, which is a minus b, a plus b, if we should expand this bracket, this a multiplies this a times a gives us a times a gives us a squared. Then a times b gives us ab. And then we use this b to multiply everything in this bracket. Negative b times a will be negative ab. And negative b times b will give us negative b squared. So this and this would cancel, giving us a squared minus b squared. So this is basically the idea of difference of 2 squares. So this is how difference of 2 squares work literally, yeah. So with that understanding of difference of 2 squared cleared out, what it basically means is that 3m squared minus 1 squared is the same as 3m minus 1 multiplied by 3m plus 1. That is well understood. Now let's repeat what we have out here in the next bracket, in the next fraction, yeah. So 1 divided by 2 into bracket 3m plus 1. So we have that handled. Now let's find the LCM, the least common multiple of the denominators. The least common multiple of the denominators. This is where it becomes a little difficult for some students, because we have algebra as the denominator and we have to find the LCM of this algebra. It doesn't come intuitive to most students. But if we say the least common multiple of this algebra, we will just have to check the two denominators. We have 3m minus 1 here, and we have 3m plus 1 out here. Now, what is common between the two? What is common? We have 3m plus 1 and 3m plus 1. So this and this are common. So when it comes to algebra, in order to find the LCM, check the value that is common and pick that out. So 3m plus 1 is common, so we would pick 3m plus 1 out. After that, the ones that are not common, for example, 3m minus 1 and 2, this and this are present in the denominators, but they are not common to both sides. So you pick the common one and use it to multiply the remaining factors or the remaining denominators that are not common. So that would be 2 times 3m minus 1 times 3m plus 1. So that becomes our denominator. So let's write out our denominator really quick, and then we'll move on to the next step. Let's wipe out everything we have here. So our LCM becomes 2 bracket opens 3m minus 1, 3m plus 1. Yeah. So we've got our denominator. Yeah, we are getting home really quick. Now, how do we proceed from here? You would pick the denominator that you have and divide it by you pick the LCM that you've gotten, the common multiple that you've gotten, and divide it using the LCM or using the denominator of each of the fractions. This is what I mean. You pick 3m minus 1 times 3m plus 1 and divide it by 3m minus 1, 3m plus 1. If you would see clearly, you would see that this LCM here can be divided by this, because this will cancel this and this will cancel this, and to be left with only 2. Why? Because 3m minus 1, 3m plus 1 is the same as 3m minus 1, 3m plus 1. So the whole of this takes care of the whole of this, leaving us with 2. So this 2 times 3 plus, so we've gotten that cleared out for us. So it becomes easy for us to handle. Good, let's clean. I think, okay. So we have 2 times 3, which becomes the top. So minus, now we have this denominator taking care of 2 and 3m, leaving us with 3m minus 1. And 3m minus 1 times 1 gives us 3m minus 1. So that is cleared out for us. So what do we have next? 3 times 2 is 6. 6 minus 3m plus 1, all divided by, I think I need some space at the top. So let me just clear out some spaces whilst and make room for the next thing. Good. So I'm actually going to wipe out the original question so that will create room for continuing from where we ended. So we'll pick out this and write it at the top. I hope you are ready. So 2 times 3 gives us 6. 2 times 3 gives us 6. 6 minus 3m minus 1, all divided by the denominator. And the denominator, how do we have? We have 2, bracket opens, 3m minus 1, bracket opens, 3m plus 1. So that is what we have out there. Do you think there is a way we can proceed to simplify it further? Is there a way we can simplify this further? That is a question, and I'm going to leave that for you to think about. Is there a way we can simplify this further? We'll leave it for you to think about. Yeah. Literally, actually, just think about it. Is this all how far we could get to? Or there's something else we can do about it? Do you think we can simplify this further? So I'm going to leave that to you. So if there is a way to simplify further, I would love to see from you, and that will give me an indication that there is some kind of learning going on. But however, there's a way we can expand on this. You have 6 times 3m plus 1. Because this negative multiplies what is in the bracket, gives us 3m. 1 times negative 1 times negative 1 gives us positive 1. And then 6 plus 1 is 7. So let's finish this up. Minus 1, 3m plus 1. So the best way to finish this up is to just write 6 plus 1 is 7. So I would like to write this 3m plus 7. Then we have 2 3m minus 1, 3m plus 1. Good. Easy peasy. Easy peasy, right? Let's pick our next question. Our next question. So this is our next question. This is going to be very simple. Yeah. So we have 6 PQ, 6 PQ minus, let's move it this way, 6 PQ minus 3RS plus 3QS plus or minus 6PR. 6PR. So we are to factorize this question completely. You have to factorize it as much as we possibly can. As much as we possibly can. First things first. What's the first thing we have to do? The first thing we have to do when it comes to simplifying this kind of expressions is to group terms that have similar alphabets in them. Terms that have similar alphabets. So we have 6PQ here. I have 3QS. So there is a Q and there is a Q here. So that means we can group this as 6PQ and then bring this closer to give us 3QS. I love that. Now let's just rearrange the rest. 3RS minus 6PR. So we are done arranging successfully. Successfully arranged. I just want to believe that we've all gotten to this point. Now the next thing we got to do is to factorize them. What I mean is this. Let me put a bracket around the pairs. So we have this as one set and this as another set. So we are going to factorize each of the brackets. And when we say we are going to factorize each of the brackets, what we basically mean is that between the 6PQ plus 3QS, what numbers are common? If you are able to detect the number that is common, we pull out that number which is common, and then we leave the rest in the brackets. So for the first one, Q is here, Q is here. So definitely Q is a common factor. And between 6 and 3, the factor common between 6 and 3 is 3. So basically, we can pull out this, which is 3Q, as a factor. Now, we pull out 3Q, what is left? For the first one, which is 6PQ, we'll be left with 2P. Good. This step can be verified. We can actually verify to see if our answer is correct or not. How can we verify that? You just multiply. So 3Q times 2P, you will get 3 times 2 gives you 6, and Q times P give you PQ. So you see, we've actually not changed anything. Yeah. We actually not changing anything. Yep. Easy, right? That's one interesting thing about maths. You can always cross-check your answer to be sure what you are doing is the right thing. So even before you leave the exam hall, you can assess yourself to know whether you were doing the right thing or not. Okay. What do we have next? We have this side. We've taken out 3Q already. So what is actually left is just S. So we have plus S. Plus S. Does it end there? No way, it doesn't. It doesn't end there. What do we have next? Now we have 3R, sorry, 3RS and 6PR. Automatically, you would see that the R is common. R is here, R is here. Good. So you have R on both sides. R, R. So if R is common on both sides, that is R is present here, R is present here, what you're just going to do is to pick this R out, and the common factor between 3 and 6 is still 3. So you have 3R as a common factor. When you pick 3R here, you have S left out here, and here becomes plus. And what are we left? We have 2P. Good. Now look at something. We have 2PS and you have S plus 2P. S plus 2P is the same as 2P plus S. You know that? Yeah. S plus 2P is the same as 2P plus S. So because this bracket, the input, the things in this bracket are basically the same as what is here, what we are just going to do is to just pick one of the brackets, pull it out, and put the remaining stuffs into the next bracket, which is 3Q and 3S. So we have 3Q minus 3R in the next bracket. If you're able to get to this stage, then you are basically done with what you have to do. So we have 2P plus S and have 3Q minus 3R. Easy peasy. Good. Next question. Do we even have a next question? Yeah, I mean. Oh.